Here we go. Angle X and angle Y are corresponding. That means that they are congruent. Angle X and angle Y are alternate exterior angles. That means they are congruent. Angle X and angle Y are corresponding angles. Angle X and angle Y are consecutive interior angles or co-interior angles. That means they sum to 180 degrees, or put another way, they are supplementary. Angle X and angle Y are alternate interior angles, also known as Z angles. Angle X and angle Y are alternate exterior angles. Angle X and angle Y are alternate interior angles, but you may not see this. So I'll point it out. There and there. They are alternate interior angles. Angle X and angle Y are alternate exterior angles. I'll point out the transversal. That's the pair of parallel lines. That is the intersecting line. And here are X and Y alternate exterior angles, meaning they are congruent. Angle X and angle Y are consecutive interior angles or co-interior angles, meaning they sum to 180 degrees or pi radians, also known as they are supplementary angles, and that means they are supplementary angles. Angle X and angle Y are corresponding angles. There are the two parallel lines of the transversal, and there's the intersecting line of the transversal. There's X and Y corresponding and thus congruent angles. Now we must find the measure of each angle indicated, and we must give a reason for the chosen measure. 110 degrees, and the reason being it is alternate exterior with this angle down here. 84 degrees, the reason being it is alternate interior, or Z angles. In a transversal, 80 degrees, as they are consecutive interior or co-interior angles. $111 degrees, as they are alternate interior angles, although in this particular case they are obtuse, and so it doesn't quite look like a Z. Again, these are alternate interior angles, and therefore this is 180 take 125, which is 55 degrees. This is 47 degrees because it's an alternate exterior angle and thus congruent to that one down there. 53 degrees, as these are corresponding angles. 113 degrees. They are congruent because they are alternate interior angles. And now we must solve for x. 21x plus 6 equals 90. Reason being alternate exterior angles. And now solving for x, this is a simple two-step linear equation. So it's 84 over 21, which is 4. 11x take 2 equals 75. Reason being they are corresponding angles, and so it's another two-step linear equation, and so x equals 7. Eight x take 4 equals 60 degrees. Reason being they are alternate interior angles, or Z angles, and so x equals 8. X had 139 equals 132. Reason being they are alternate interior angles as well, and thus they are congruent, and so x is equal to -7. -1 add 14x equals 12x add 17. Reason being they are alternate exterior angles. And so solving this, x is 9. 23x take 5 equals 21x add 5. Reason being They are corresponding angles. Corresponding angles. And so x is 5. All right, so not quite sure what's going on here. So x at, well, okay. 2x at 192 equals 180 because they're consecutive interior or co-interior angles. And so x equals -6. And of course, this angle here is 90 degrees. But I'm not sure what they're actually asking there. These are consecutive interior or co-interior angles as well. So 44x plus 4 equals 180. Consecutive interior. And so 44x equals 176. And so x equals 4. So the bold angle is 85 degrees. And indeed it looks acute, so it looks fine. Six x equals 5x. 6x equals 5x at 10. Corresponding angles. And so x must be 10 itself. And so this must be 60 degrees. They're consecutive interior angles. And so 2x at 198 equals 180. And so x equals -9. And so this angle here is 80 degrees. But it's because they are co-interior or consecutive interior angles. Okay. Now to check. That was silly. Of course. All correct. Except for one. Find the measure of the indicated angle that makes lines U and V parallel. That would be 130 degrees, and I will give the reason because they would have to correspond with each other. That would be 128 degrees, and I shall give the reason. It's because they would have to be alternate interior with one another. 66 degrees. The reason being they would have to be alternate exterior angles. 100 degrees. The reason being they would have to be consecutive interior angles. 90 degrees. Same story. I'll use the synonym, the UK synonym. 81 degrees, as they would have to be corresponding angles to one another. 53 degrees, as U and V are the parallels of a transversal, this line here being the line which intersects them, or the intersecting line, and so these would have to be corresponding angles. 58 degrees, alternate interior angles. 50 degrees, co-interior or consecutive interior angles. 180 take 117, so 63 degrees, as they would have to be co-interior or consecutive interior angles. Now find the value of x that makes lines U and V parallel. 16x take 6 would have to equal 90 degrees. Would have to equal 90 rather, as it would have to be alternate interior angles. So x would have to equal 6. 12x take 4 would have to equal 10x at 10, as they would have to correspond to one another and thus be congruent to one another. So 2x equals 14, so x equals 7. X set of 112 would have to equal 105. They would have to be alternate exterior angles, and thus x would have to equal -7. 19x take 4 would have to equal 110. There would have to be alternate exterior angles, and thus 19x would have to equal 114, and thus x would have to equal 6. $11x take 2 would have to equal 130, as there would have to be corresponding angles to each other, and so x would have to equal 12. And lastly, in this batch, 7x at 14 would have to equal 8x at 6, as they would have to be alternate interior angles, And so x at 6 would equal 14, so x would have to equal 8. Now we must find a value of x that makes lines u and v intersect. In other words, we would have to find a value of x that would make 8x at 6 smaller. Interesting. Okay. Oh, would we? Oh, beg your pardon. It could literally be anything. Even if the lines in question 16 were not parallel, could x equal 25? Why or why not? 25 times 8 is 200. So 206 degrees there. And no, they couldn't, because it would have to be less than 180 degrees. And now to check. Oh, right. I could have remarked that x would still have some kind of boundaries. Right, okay. Right, that's all complete. Next up, points in the coordinate plane, or the xy plane. Five, 10, 1, 9, 6, -9, 6, -8, 9, 0, -6, 0, -8, -4, 5, 0, -1, -1, -8, -1, done. 7, 10, wrong. 7, 10, 0, 4, -1, 10, -6, 6, -6, -6, 10, 0, 9, 7, -3, -4, -4, -9, 4, 1, and 7, -9. Now, I'm curious what the most prevailing convention is for specifying a point with that is indicated by a capital letter. Gotcha. Abscissa and ordinate. All right, and it's settled. We shall name our points and specify them as was done up here. So, -10, 2, 6, 10, -8, -3, -8, -8, 1, -5, 2, -4, -7, 8, 2, 5, 8, -2, -7, -5. There. Those are coordinates. Coordinates with the ordinate and abscissa. Or did I get that the other way around? The abscissa is the x-coordinate or horizontal position, and the ordinate is the y-coordinate or the vertical position. Okay, AO. Got it. Okay, so these are sort of no longer in order. So what I'm going to do is I'm going to go quadrant by quadrant. And let's also find out the name or the convention for when a point is on an axis. What is the way to say, we would say 3,2 is in quadrant I just want to be sure. Right. I want to be more rigorous about my terminology and adherence to mathematical conventions. I know it seems fussy, but fussiness in the foundations is actually good. I think I've heard a specific adjective for quadrantal point. quadrantal. Quadrantal is usually applied to angles. Okay. All right. Back to the task. Yes, going quadrant by quadrant. 0, 0, 3, 4. Quadrant I. And yeah, I like that. Okay, so point I lies on. No, do we say lies on? I think so. Point I is 3, 4. G is 10, 4. M is 10, 2. And in quadrant 2, K is -7, 2. In quadrant 3, L is -7, -7. N is -3, -8. And J is -3, -10. E is 5, -9. And F is 5, -4. State the quadrant or axis that each point lies in. This is in quadrant 2, quadrant 3, quadrant 1. This is in quadrant 2, positive x-axis. This is quadrant 2. This is quadrant 4, quadrant 1, quadrant 2. This is in the positive x-axis. Quadrant 4, and the positive x-axis. State the coordinates of the endpoints of a line segment that intersects the y-axis. So, as it intersects the y-axis, that's it. That's all I know, is that it intersects the y-axis. Well, our endpoints of the segment. And if it intersects the y-axis, so either a is less than 0, sorry, a is less than or equal to 0. Oh, this is kind of interesting, actually. A is less than 0, and B, and C is greater than or equal to 0. Less than or equal to 0. And C is greater than 0. Or, quite simply, the other way around. State the coordinates of the endpoints of a line segment that is not parallel to either axis and does not intersect either axis. All right, so we're supposed to just give an example. Okay. I like simple examples. Is not parallel to either axis and does not intersect either axis. Okay. How about that? Nice. Okay, so I'll mark these ones. 2, 3, 1, good. 2, x-axis, 2, good. 4, 1, 2, good. Positive x-axis, 4, positive x-axis, good. And nearly the same. And that's good. Okay. That was handled nice and well, and be well.